Today we're diving into the fascinating world of circles. Circles are everywhere around us, from wheels to coins and even in nature. But what exactly makes a circle unique? In this video we'll explore the essential properties that define a circle, how they relate to each other, and why they matter in both mathematics and our daily lives. Whether you're a student, a teacher, or just curious, understanding circles will give you a new perspective on the shapes you see every day. Let's start by defining what a circle is and why it's so special compared to other shapes. Circle is a simple closed shape. All points on the circle are the same distance from a fixed point known as the center. This constant distance is called the radius. Imagine tying a string to a pencil and spinning it around a fixed point on paper. The path the pencil traces is a perfect circle. This definition is the foundation for all the properties we'll discuss. The center and the radius are the two most important features that set circles apart from other shapes, and they're the starting point for understanding everything else about circles. Center of a circle is the fixed point from which every point on the circle is equally distant. It's like the hub of a wheel anchoring the entire shape. No matter where you measure from the center to the edge, the distance is always the same. This property is what gives the circle its perfect symmetry. In diagrams, the center is usually marked with a dot and labeled with a letter, often O. Understanding the center helps us define other important parts of the circle, such as the radius and diameter. Radius is the distance from the center of the circle to any point on its edge. Every radius in a circle is the same length. If you draw several lines from the center to the edge, you'll notice they're all equal. This is a key property that makes circles unique. The radius is often labeled with a lowercase r in formulas and diagrams. Knowing the radius allows us to calculate other important measurements like the diameter and the circumference, which we'll discuss next. Diameter of a circle is a straight line that passes through the center and touches 2 points on the edge. It's the longest distance across the circle. The diameter is always twice as long as the radius. If you know the radius, you can easily find the diameter by multiplying it by 2. The diameter is often labeled with a lowercase. This property is useful in many real-life situations like measuring wheels or round tables. Circumference is the total distance around the edge of the circle. It's like the perimeter of a polygon but for a round shape. To find the circumference, you can use the formula c equals 2 pi r, where r is the radius and pi is a special mathematical constant, approximately 3.14159. The circumference is important in many practical applications, such as calculating the distance a wheel travels in one rotation. I, represented by the Greek letter pi, is a unique number that appears in every circle. It's the ratio of a circle's circumference to its diameter, and it's always the same no matter the size of the circle. Pi is an irrational number, meaning it never ends or repeats. In calculations, we often use 3.14 or 27 as an approximation. Pi connects the diameter and circumference in a simple, elegant way. Chord is a straight line that connects 2 points on the circle's edge but doesn't necessarily pass through the center. Chords can be short or long, but the longest chord in any circle is the diameter. Chords help us divide circles into segments and are used in many geometric constructions. They're important in understanding how circles interact with other shapes and lines. An arc is a portion of the circle's edge or circumference. It's like a curved line between 2 points on the circle. Arcs can be small or large depending on the angle they cover. In geometry, arcs are often measured in degrees. Arcs are used in many designs from bridges to logos and help us understand the circle's structure in more detail. Segment is the region inside a circle bounded by a chord and the corresponding arc. Imagine slicing a piece of pie but not all the way to the center. That slice is a segment. Segments are useful in geometry problems and in real life, like designing windows or arches. They help us calculate areas and understand how circles can be divided. Sector is the area of a circle bounded by 2 radii and the arc between them. It looks like a slice of pizza or pie. Sectors are used to represent portions of a whole, like in pie charts. The area of a sector depends on the angle at the center. Sectors help us visualize fractions and percentages in a circular way. Tangent is a straight line that touches the circle at exactly 1 point. This point is called the point of tangency. Tangents never cross into the circle, they just graze the edge. Tangents are important in geometry and engineering, especially when designing wheels, gears, or roads that curve. They have unique properties like being perpendicular to the radius at the point of contact. Secant is a straight line that passes through a circle, crossing it at 2 points. Unlike a chord, which is just a segment inside the circle, a secant extends beyond the circle on both sides. Secants are used in advanced geometry and trigonometry, and they help us understand how lines interact with circles in different ways. Concentric circles are 2 or more circles that share the same center but have different radii. Think of ripples in a pond after you drop a stone. Each ripple is a circle and they all have the same center. Concentric circles are common in art, design, and nature. They help us understand patterns and symmetry in circular shapes. Equal circles are circles that have the same radius and therefore the same size. They may be located anywhere, but as long as their radii match, they're considered equal. This property is important in geometry when comparing or constructing shapes. Equal circles are used in design, engineering, and even in games where uniformity matters. Chords have some interesting properties. For example, the perpendicular from the center of the circle to a chord always bisects the chord, dividing it into 2 equal parts. Also, chords equidistant from the center are equal in length. These properties help us solve geometric problems and prove theorems about circles. Angles play a big role in circles. The angle at the center formed by 2 radii is called the central angle. The angle at the circumference formed by two chords meeting at a point on the circle is called the inscribed angle. Central angles are always twice the inscribed angles subtending the same arc. This relationship is key in many geometric proofs and constructions. Cyclic quadrilateral is a four-sided figure where all the vertices lie on the circumference of a circle. The opposite angles of a cyclic quadrilateral always add up to 180 degrees. This property is useful in solving complex geometry problems and is often seen in mathematical competitions. Circles are everywhere in our daily lives. From the wheels on your bike to the face of a clock, circles are used in countless designs and structures. Their properties make them ideal for things that need to roll, rotate, or be evenly distributed. Understanding circles helps us appreciate the design and function of everyday objects. Area of a circle is the space inside its boundary. To find the area, use the formula A equals pi r 2, where r is the radius. This formula is essential in many fields from architecture to engineering. Knowing how to calculate the area helps us solve problems involving land, materials, and even food portions like pizzas and pies. It's important to distinguish between circumference and area. The circumference measures the distance around the circle while the area measures the space inside. Both use the radius and pi in their formulas, but they answer different questions. Understanding the difference helps avoid confusion in calculations and real-world applications. The radius, diameter, and pi are closely linked in all circle calculations. The diameter is always twice the radius, and pi connects both to the circumference and area. Remembering these relationships makes it easier to solve problems and understand how circles work in math and science. Let's quickly recap the key formulas for circles. Circumference equals 2 pi r or pi, area equals pi r 2, and diameter equals 2r. These formulas are the backbone of circle calculations. Keeping them in mind will help you tackle a wide range of geometry problems from simple to complex. Circles are perfectly symmetrical. Any line through the center divides the circle into two equal halves. This symmetry is why circles are so pleasing to the eye and useful in design. Symmetry also makes calculations and constructions easier as every part of the circle behaves the same way. Artists and designers love circles for their beauty and balance. Circles appear in logos, architecture, and even in famous paintings. Their symmetry and simplicity make them a favorite choice for creating harmony and focus in visual compositions. Nature is full of circles, from the sun and moon to ripples in water and tree rings. These natural circles remind us that the properties of circles aren't just mathematical, they're part of the world we live in. Observing circles in nature can inspire curiosity and appreciation for geometry. Technology relies on circles in many ways. Gears, wheels, and even computer graphics use circles and their properties. Understanding circles helps engineers and designers create efficient, reliable machines and digital images. Circles are truly at the heart of innovation. Sports fields and equipment often use circles. Think of basketball hoops, soccer balls, and running tracks. The properties of circles ensure fairness and consistency in games. Circles help define boundaries, targets, and paths for athletes. Architects use circles to create stunning buildings and spaces. Domes, arches, and round windows all rely on the properties of circles. Circles provide strength and beauty, making them a popular choice in both ancient and modern architecture. Wheels are one of the most important inventions in history, and they're based on circles. The circular shape allows for smooth rolling and efficient movement. Whether it's cars, bicycles, or trains, the properties of circles make transportation possible. Clocks use circles to measure time. The hands of a clock move around a circular face, dividing time into equal parts. This use of circles helps us organize our days and keep track of important events. The symmetry and regularity of circles make them perfect for timekeeping. Circles are used in communication symbols like the iconic speech bubble or the circular buttons on devices. Their shape is easy to recognize and draws attention. Circles help make information clear and accessible in our digital world. Many cultures use circles in their art, rituals, and symbols. Circles often represent unity, eternity, and wholeness. From wedding rings to mandalas, the circle's properties carry deep meaning and significance across the world. In mathematics, circles are studied in geometry, trigonometry, and calculus. Their properties help us solve problems, prove theorems, and understand more complex shapes. Circles are a foundation for much of mathematical thinking and discovery. Scientists use circles to model everything from atoms to planets. The properties of circles help explain natural phenomena like orbits and waves. Circles are a powerful tool for understanding the universe at every scale. Engineers use circles in designing gears, pulleys, and many other machines. The uniform properties of circles ensure smooth operation and reliability. Circles are essential in creating efficient and effective mechanical systems. Astronomers observe circles in the orbits of planets, moons, and stars. The circular paths help predict movements and understand the forces at work in space. Circles are a key part of exploring and explaining our universe. Music uses circles in many ways, from the circular shape of drums and records to the circle of fifths in music theory. Circles help organize notes, rhythms, and harmonies, making music more structured and enjoyable. Many foods are circular, like pizzas, pies, and cakes. The properties of circles help us divide food evenly and share it with others. Circles make serving and portioning easy, and they're a familiar shape at the dinner table. Games often use circles, from board game pieces to sports balls. The properties of circles ensure fairness and balance in play. Circles help define rules, boundaries, and objectives in many types of games. Circles are used in many symbols like the peace sign, traffic signs, and company logos. Their simple, closed shape makes them easy to recognize and powerful in communication. Circles convey messages quickly and clearly. Fashion designers use circles in patterns, accessories, and jewelry. The round shape adds elegance and interest to clothing and style. Circles are a timeless element in fashion, appearing in everything from buttons to prints. Jewelry often features circles, like rings, bracelets, and pendants. The unbroken shape of a circle symbolizes eternity and unity. Circles add beauty and meaning to personal adornment. Festivals and celebrations use circles in decorations, dances, and rituals. Circles bring people together, symbolizing community and joy. Their properties make them perfect for creating inclusive and festive environments. Circles are more than just shapes, they're a fundamental part of our world. Their unique properties make them essential in math, science, art, and everyday life. From the smallest atom to the largest planet, circles help us understand, create, and connect. By exploring the properties of circles, we gain insight into the patterns and structures that shape our universe. Thanks for joining this journey into the world of circles.